We've been working hard at PASCO to help support teachers who are teaching remotely. Yesterday, we rolled out our distance learning for teachers and students page. You'll see that in a banner at the top of our main website, pasco.com. Just click on that, and you'll see an amazing set of resources. One I wanted to talk about specifically here is the student and teacher access to our Essential Physics 3rd edition textbook. You should also check out the chemistry one. I'm going to talk about the physics one. And so students can go to this page, get the access code, and have access to a textbook, but this textbook integrates labs and activities in a way no other textbook does. And I'm going to show you the teacher version, which you can get if you fill out this request form. And so here's the home screen, and you can take a look at the contents. I'm going to highlight the things I would be using if I was still teaching and doing distance learning to try and keep my students engaged during this crisis. And so I selected a few resources here I wanted to show you. And so here now I'm in chapter 14, maybe some topics that some of you are in or recently have done. And you'll see a very engaging text with essential questions and figures. But I wanted to specifically look at the interactive simulation. And so if you click here, they have a spring oscillator simulation. And yeah, it's kind of cool and fun to play around with, but what do you do with it? Well, up here, there's for the student version looks just like this, except they don't have this sidebar. And so there's a lesson plan that goes with this, a slide presentation that you could download and narrate and put out as a video for your students. But there's an activity sheet that goes along with the investigations, and then also an answer sheet that you can get a hold of. So let's take a look at the activity sheet for this one. And you can see it's well structured. It gives them a background for what they're doing and has them do apply a lot of things they've already learned in their class to what's going on with the simulation. And then there's a application, shock absorbers in a car. And so they have this, and then you also have a key that you can help them with if they're having trouble. If we go flip pages here, you can see there's more to the book. This is written at an honors level. Definitely most of it is accessible to a regular physics level, and some of it would be applicable to an AP class, but definitely an honors comprehensive level physics class. So here I'm at the end of section 1, and there are review problems. And so the student can quiz themselves to see if they're getting the idea. And if you click show solution, they can check themselves. Also, at the bottom is a take a quiz, which generates a random set of questions that the students can take over and over again and see their score. And so this can be used for them to self-evaluate. You can also have them print it out and send it to you if you want to use it as a assessment. And so that's just one example. Let's go to another chapter here in chapter 15. Again, all the teacher resources. There are labs in here, but without lab equipment at home, that gets a little harder. We did do some resources to help with that we'll talk about in another video. But here's another simulation. This one I like a lot. And so you can do all kinds of things. Here I'm going to look at diffraction with 2 gaps and run. And so not only does it give engaging visual, there are numbers for them to do some analysis, and they can also input their own. They use the keypad to enter things because this also works on phones and things. This is all HTML based. And as with the other one, there's a student handout. Let's take a look at that just real quick. I've already flipped down through it. And so, again, very detailed directions, gives them a context, background, why are they doing this, and instructions for an activity associated with that simulation. Let's jump to another topic that some of you may be trying to do in this trying time. And here's a electric field simulation. And again, a lot of things for students to manipulate, and they show the electric field, and they can put more charges on and go along with the handout up here. And so again, another student work handout. You could download the doc version and edit it, add things, subtract things if you wanted. The PDF looks like this. And again, detailed instructions to guide them through this, and you come up with your own ideas to add to it as well. Another reason to have that .doc file. And the same thing if we flip through the chapter, you can see what they would, if you assigned reading out of here. Then at the end of the section are some review questions with a detailed solution, and then also an interactive quiz. Every time they do this, if you say new, it generates a new set of numbers. So if they had trouble with one or two of them, they finally got it, they could generate a new version of it to see if they're really getting it. And then one more here. There's tons. I just highlighted a few. It was hard to even choose which ones to show you. And so this was the optics sim, and it's on 623. No, wrote the wrong. 620. And so this one, they can draw rays to show what they think is going to happen with image formation. And then they can check themselves out and see if they got it, and it gives them a score. And so I got 0, but they'll do better. And again, there's a detailed handout that guides them through this, but this one you could definitely add a lot to it if you're doing some ray tracing. So it makes a game out of ray tracing. And then here's a lab that they won't be able to do, but we are making videos where we go through the data collection on a lab and then give you the handout and the data file so they can do some lab analysis at home as well. And so check that out on our page. I hope you find these useful. Give them a try, and hopefully this will help your students keep up at least somewhat with their learning over the next few weeks.